No. And the federal government can't mandate that. The federal government can't make you wear a mask either, if you didn't know that. The only person that can make you wear a mask is the local health department. Let's see. So no y-axis symmetry. I guess we'll do a test for x-axis. How do you do a test for x-axis? Yeah, the y value changes signs. So again, f of x was x cubed. And negative f of x would happen when we just multiply this thing by a negative, wouldn't it? So negative x cubed. Have it? No. All right, test for origin. What's that test look like? F of negative x equals negative x equals negative f of x. We've already done all the work for this. F of negative x was up top. It was negative x cubed. And negative f of x ended up being negative x cubed. So what we have is we have origin symmetry. Most textbooks make a big deal out of this. What they're hoping a kid will do is they'll just plug in a couple of points to the right, like they'll plug in 0, 1, and 2. That's what they're hoping the kid will do. And then you can use that origin symmetry, and you can just create the other tables. So it does say by plotting points. So maybe you plug in a 0, 1, and 2. If you plug a 0 into x cubed, what do you get back? You get 0. If you plug a 1 in, what do you get back? 1. 1 times 1 times 1 is 1. Plug in a 2, what do you get back? 8. Now, they're hoping that you'll use the idea of symmetry to finish out the rest of it. So this is where I'm plugging in this negative f of x. It's supposed to equal negative f of x. So the value at negative 1 is supposed to equal the opposite of the value at positive 1, which is what? The value of y at negative 1 is supposed to equal the opposite value of y when x is 1. Does that hold? Is a negative 1 times a negative 1 times a negative 1 still negative 1? Yeah. And the value of y at negative 2 is supposed to equal the opposite value of y when x is 2, negative 8. That's what they're hoping you'll do. But you'll realize that that's because of the origin symmetry that you just switch the signs. But I don't think you will. I wouldn't. I'd just make a small table and go with it. Plus, you're supposed to memorize what she looked like anyways. This was the mother function, y equals x cubed. It's that sideways snake that likes the y-axis. It does have origin symmetry. One thing your book doesn't talk about is what origin symmetry is. That is the line y equals negative x. That's the line it's reflected upon. Kind of hard to see, but it is. All right, moving on. We're supposed to graph this one. Graph the equation x equals y squared and find any intercepts and check for symmetry first. We'll see what happens. X-axis. What do you place x with? Well, actually, I guess the first thing you should probably do is solve this thing for y, isn't it? So solve it for y. How do you solve that equation for y? Are y'all too busy listening to sex ed? What's going on here? Solve that equation for y. Huh? Yeah, take the square root of both sides. So y would be plus or minus root x. Now, how do you do the x-axis symmetry? Hmm? No. You make y negative, don't you? Or in other words, you multiply the whole thing by a negative. So f of x is actually plus or minus root x. Negative f of x is what happens when you multiply the other side by a negative. And if you multiply the plus or minus symbol by a negative, what do you still get? You still get plus or minus. This thing has x-axis symmetry. And it's done. That's all that thing has. This one actually says, I didn't do it on the last one. It says, but we found them anyways. Find any intercepts and check for symmetry first. So let's talk about our x-intercepts. Where do x-intercepts happen? Happen when y is 0. So I'm going to replace that y with a 0. 0 is plus or minus root x. Then you're going to counteract the root. How do you counteract the root? Well, you know what? It didn't even make sense to use it there. X equals y squared was the original equation, wasn't it? So if we plug that 0 in, what's it say about x? 0. So we have an x-intercept at 0, 0, because y was 0 and we got a 0 back. How do we find a y-intercept? We let x be 0. You can plug that into either two equations. You can plug it into the first or the second. It doesn't matter. But if you say y equals plus or minus root 0, the equation we came up with, what's it return? Y'all are got to be screwing with me the last couple of days. What's the square root of 0? Like, did you forget to talk? Do you meet up every morning and be like, let's just mess with Mr. Milbrath-Math's head and we're not going to say anything for 45 minutes? Is that what you're doing to me? You're ruining my day. Quit ruining my day. Talk to me. You're my first class. You like set the mood for the rest of the day. You really do. Don't I kind of set your mood for the rest of the day? No? You just pretend this class never happened when you leave? It shows. Your grades show it, kids. All right, so we found the x and y intercepts. Let's make a little table. We know this one. What do you want to throw at that thing? Make up a number. Give me a number. Want to throw a 1 at it? What's the square root of 1? 1. Any other numbers you want to throw at it? Huh? Yeah, 4. What's the square root of 4? What would happen if you threw a negative number at it? What if you threw a negative 4 at it? Imaginary. Not real. You know, when you make a table for a square root function, you got to use a little common sense. You guys picked 1 because you could take the square root of 1, right? You picked 4 because you could take the square root of 4. Now, we learned that this thing had x-axis symmetry, so what we're going to do is we're going to draw the points we've plotted, 0, 0, 1, 1, and then 4, 2. Now, we actually have another set of points. Now, here's what we plotted. But not only did we have a y value of 1, we also had a y value of what? Negative 1. We have x-axis symmetry. Plus we had the plus or minus symbol. Not only do we have a y value of 2, we had a y value of negative 2 because we have x-axis symmetry. The square root function, when you graph both plus and minus aspects, is actually just a sideways parabola. As long as you graph both pieces. Makes sense. Square rooting is opposite of squaring. What's squaring look like? Parabola opens up and down, right? So its inverse opens left and right. It's opposite function. Well, these are always fun. Graph y equals 1 over x. Check for symmetry first. So I'm going to make a little table here instead of just doing everything at once or a step by step. Here's f of x. What would f of negative x look like? Wouldn't it be 1 over a negative x, which is negative 1 over x? And the last one that we do when we find these symmetry tests is we do negative f of x. What would it look like? Negative 1 over x. Now look at your rules about symmetry. What type of symmetry does this thing have? I can't hear you with the mask on. You got to talk louder through a mask. Origin, that's right, Savannah. This is origin symmetry. So what I'm going to do is I'll make a table with positive x values and use the values I get back and flip them. Change your signs. That's kind of the point of doing this. Of course, the reality is you just quickly make a table and plug numbers in because it's an easy function. Like I said, they want you to go somewhere with this, and that's where they want you to go. So let's make a table here with some positive x values. And just give me something you'd like to plug in. Want to plug in a 0? Well, we'll plug in a 0. You plug in a 0, what do you get? You get 1 over 0. You get error if you go to a calculator. You get undefined. So the thing doesn't actually cross the origin. Want to plug in a 1, what do you get? Another 1. What else you want to plug in? Give me a number. 2. What do you get? You get a half, right? Give me a big number. 10? I think I heard 10. Is 10 a big number nowadays? 1/10? Give me a bigger number. 100. Now think for a few seconds. Where is this thing going? Huh? Get not closer to the origin. As x gets big, what's happening to y? It gets smaller. It gets closer to what though? X-axis is what Kelly's saying. She's right. You're playing on her phone. So say you put in like a huge number. What does y get really close to? 0. Now, one of the things we didn't explore here is what happens when you get close to, like we went, there's some interesting stuff on this function between 1 and 0. It really is. What would happen if you plug in something like a half? What's 1 divided by a half? 2. Isn't it, kids? Give me another fraction. Smaller than a half. 1/4. What's 1 divided by a quarter? 4. Let's go with that big fraction, or the little fraction, in this case 1/10. What do you get? 10. Now what's happening as the x values approach 0? As x approaches 0, y approaches what concept? Think about this on the graph, what's happening. That thing is really, really starting to ramp up speed and go straight up. What is y approaching as x approaches 0? Infinity. When you plug in a 0, you get an infinity back. You never get to be that 0 because it's just impossible, but you get an infinity back. I'm not going to make a secondary table of values. I'm not even plotting points. That's what our table of values is suggesting happens, isn't it? Now, I talked about this in the example right above. This example above was origin symmetry. We reflect on that line. All you do is you flip over that line, kids. You get that right there. That works for origin symmetry. Reflect on y equals negative x. And that is that. So if you need any help with your homework, I'm here to help. If you want to give me some quiet time, I'm good with that too. It's entirely up to you.